Hey everyone, this is Mr. Schultz here, and we're going to be taking a look at some advanced exponent work here. So I'm going to go through this with a little bit of speed here. So if you need something a little bit slower, feel free to slow down the video, to pause it, to do things like that. But I'm going to go through it with a little bit of efficiency here. So on the first one, anything to the 0 power. So any number, doesn't matter if it's a variable, doesn't matter if it's a number, raised to the 0 power is just equal to 1. So that one's just equal to 1. So even though it's an exponent, same thing. Also just equal to 1. So now this here, 4 raised to the 0 power, that's just equal to 1. So what I'm really saying is, what is 1 times by 4 to the 6th? Well, I'm just going to call that 4 to the 6th power, and that's it. If you really want to know what that number is, of course you could do it. I don't really want to write this number out because it's just kind of long and seems a little bit unnecessary to me. But 4 to the 6th is fine with me. But 4,096 would be that, but 4 to the 6th power is just fine here. So let's go down to our next one here, to letter D. So a to the 0 power, again, that's just going to be 1. So what I'm really talking about here is this b to the 4th raised to the 2nd. So if you think about this in terms of exponents, if you go into expanded form, well, I'd have b to the 4th, that's b times b times b times b, and then I've got 2 of those, times b times b times b times b. So I've really got b to the 8th power. B to the 8th power would be the simplified form. So our rule here is just when you've got a power raised to a power, you can multiply the two numbers. So 2 times 4 is 8. Let's move on to our second side here. So this will be letter E through H. So again, when I've got a power raised to a power, I just multiply them. Even if they're negative numbers, same rule applies. So I've got 3 to the negative 2 times by a negative 3. Negative times by a negative is a positive. I would end up with 3 to the 6th power. Same thing here. 3 to the positive 2 times by the negative 3 would be 3 to the negative 6th power. So getting rid of that negative exponent, all that I need to do is drop that to the bottom part of the fraction, and then it becomes a positive. Because remember, a negative exponent is not a negative number. It is a very small number. Very small number. So let's go to our next one here. So now this is just saying 3/5 raised to the negative 1. So I got to make sure and get this negative 1 into both parts of this fraction. It's applying to both things. So I end up with 3 to the negative 1 over 5 to the negative 1. Same thing here, just like I dropped down this 3 down here, I need to drop down this 3 here. But then the same thing happens to the 5, but this time I'm just going to go up in the fraction. So I'd end up with 5 to the 1st power, 3 to the 1st power, same thing as 5 over 3. Let's go to our last one here. So now this one is just our exponent multiplication rule. So exponent multiplication is you can just add the exponents when you're multiplying by the same base. So to the negative 5 plus 5, well, negative 5 plus 5 would be 2 to the 0. Goes back to our first rule. This is a grand total of 1 there. All right, let's see what's on the next page. So on the next page here, these are where they start to get more complex. We're going to start to combine a bunch of different rules here. So just like we saw before, we're going to kind of give this 3 to every single thing inside of the parentheses. So I would have 3 to the 3rd power. I'd have x to the 2nd, but I've got 3 of those, so I'd really have x to the 6th. And I'd have that divided by y to the 3rd. And that's it. That's as simple as I can get it. If you want to write 3 to the 3rd is 27, also cool with me, but 3 to the 3rd is just fine. Let's move on to the next one. Same type of thing here. I'm going to kind of distribute. It's kind of like the distributive property, but a little bit different, to each of the pieces on the inside here. So I've got 6 groups of a to the 2nd, and I've got 6 groups of b to the negative 3rd. So I'd end up with a to the 12th. I'm just going to multiply, and I end up with b to the negative 18th. So my final step would just be to get rid of that negative exponent. So I'm going to move that to the bottom. So my a to the 12th will stay the same. The bottom part of the fraction becomes b to the 18th. And that's as simple as I can make it. Continuing on here, I'm just going to do the same thing. Just make sure and get that 3 to everywhere. So this will be x to the 6th power because I'm multiplying. This will be y to the negative 9th power. And this would be z to the 12th. Final step is to get rid of this negative exponent here. So I'd end up with x to the 6th times by z to the 12th over y to the 9th. That's my final answer there. Now let's get into our next step here beyond the kind of working with the powers raised to a power. So now here we can start to do some of our exponent subtraction. Because if I think about this in expanded form, if I think about the p variable and the r variable, well, this would be p to the fifth, so I just end up with 5 of those. And then also next to it, I'd have r to the third, so it'd just be 3 r's. And then in the bottom part of the fraction, I would have 2 of the p and 2 of the r. So now here's where I can just go and start to divide. P divided by p, that's equal to 1. P divided by p, that's equal to 1. R divided by 1. R, that's equal to 1. R divided by r is equal to 1. So all those 1s are just 1s, so I'd be left with just p to the third times by r to the first, if you want to call it the first, but it's just r. And what the rule is here is you've got p to the fifth minus 2 is equal to p to the third. R to the third minus 2 is equal to just r, or r to the first. So my final answer here, p to the third, r to the first. So we're going to start to see that happen more, and you'll start to see how these get more complex here as you keep going. So now here, just looking at and just subtracting like things. So the numbers here sometimes throw students off. This is just a fraction, 4 divided by 8. Well, that's just 1/2. So I know that there's going to be a 2 on the bottom part of my fraction. I'm going to go to my next part. I've got 4 x's on top and 3 on the bottom. That's just going to leave me with 1x, or x to the first, there. And then my y values, I'm just going to line those up. I have 8 on top and 5 on the bottom. That's going to leave me with y to the third right there. Looking down at some of these last ones here. So again, I'm going to just make sure this 2 goes to every single piece in the entire thing. It has to go to every single one. So I would have x to the fourth, y to the second, because I'm multiplying when it's a power raised to a power. And then we get more interesting here with this -2. So this is a -2 raised to the second power. So just be careful about how you are writing this. If you're going to include that in there, it should be something like that, because the negative needs to be included inside of that parentheses there. You would have x to the second power, and you'd have y to the sixth power. And we're just going to do all the same stuff here that we have done. So -2 raised to the second power, that's just a number, that's just 4. So that was just this guy here. Then I'm going to take my x's. I've got 4 on top and 2 on the bottom. That leaves me with 2 x's left over. And now this time I've got 2 on top and 6 on the bottom. That leaves me with 4 y's left over, but they're in the bottom part of the fraction. So my final answer is something like that, in the bottom part of the fraction. You can start to see how this gets more and more complex here. So let me go just a little bit slower on this one, and then we'll go back. So again, I'm going to just distribute this to everything. Make sure it goes to the 2, make sure it goes to the x, make sure it goes to the 3, make sure it goes to the x, all that type of stuff. So 2 raised to the third power is just 2 to the third, or 8. 3 raised to the third power is 27. So I've just done the numbers here first. If you want to write them as 2 to the third or as 3 to the third, that's also perfectly cool with me. In fact, let's actually do that just so that I can show you kind of what that looks like here. So if we do the numbers first, this would be 2 to the third, this would be 3 to the third. Then I go down to my x values next. This would be x to the 9th, because I'm multiplying. I'm going to go to my y value next. A -4 times by a +3 is a -12. Then I'll go down to the bottom part, x to the second raised to the third. This should be x to the 6th. Now, let's see what stuff we can kind of simplify here. Now be careful on this first row, because this is a 2 versus a 3. It's got a different base, so I actually just leave those exactly as they are. So that's just going to be 2 to the third divided by 3 to the third, or again, if you want to call that 8 over 27, perfectly cool with me as well. Then you've got 9 x's on the top part of the fraction and 6 on the bottom, so that's going to leave me with 3 of them on top when I subtract. But then I just have to clear this negative exponent. So I do that by dropping down to the bottom and making it positive. Y to the 12th power, final answer. So it feels like, again, that you can simplify these. But remember that these are different bases, 2 and 3. This is 3 2's and this is 3 3's. That is different. That is not, those would not cancel. Let's go to our very last one here, our hardest one. Going to distribute this -2 to every single piece here, which is going to make this one get kind of crazy. So I'm going to have 2 to the negative 2. I'm going to have x to the negative 2. I'm going to have y to the negative 4. I have 3 to the negative 2. I'm going to have x to the negative 2, and I'm going to have y to the negative 2. So tons of stuff happening here. Let's see what is going on here. So I've got 2 to the negative 2, so I'm just going to put that on the bottom. It's 2 to the second. I've got 3 to the negative 2. I'm just going to put that on top. That's 3 to the second. Again, those are different bases, so they're not going to cancel. Then I've got x to the negative 2 divided by x to the negative 2. Well, that's the same thing. So that's just going to be 1. My x's go all the way away. Then, maybe to help you see this here, my y to the second here, this piece is going to go up, and y to the negative 4th, that's going to come down. So let's just rewrite that. If we need to write something again, we sure can. So now I've got 2 y's on top and 4 on the bottom. So that's going to leave me with a grand total of 2 y's on the bottom. And my 2 to the second stays there. And my 3 to the second stays on top. So that big, long problem, this huge thing right here, simplified all the way down to something like this. And that's everything that we've got for today. If you have any questions, feel free to reach out to your teacher and go from there. But here's your homework for tonight. It's going to be 1 through 17, the odd numbers. And then, of course, 18 through 24, I want you to do all those. Those are a little bit more of the challenging ones. These are kind of those nice starter ones. That's it. Have a good rest of your day.